See, it's such an important thing to get. This formula is so important. Every function should have a derivative. Not all of them do, but some functions don't have derivatives, but most of them do. And so if we can come up with that formula, it's going to be very powerful. It's going to allow us to do quite a bit of stuff. So we have a special name for it. It's called the derivative. Now, we're going to talk about one, I guess, application of this. Okay, we're going to talk about one application. If, let me use the same notation. I have my notes so I don't. S of t, okay, S equals f of t, all right. If S equals f of t is a position function, I'll explain what I mean by position function, then f prime of t is the velocity function. I'm sorry, f prime of a is the velocity at x equals, or t equals a. So in the very beginning of this class, do you remember me talking to you about if you're driving your car? We talk about that? You're driving and you look down at your speedometer and you see your speed? At every instant, like if I'm running, I have a speed at every instant. But if you actually try and calculate it, there's a problem because you have to do distance over time and you haven't gone any distance and there's no time. So you get 0 over 0. This is just briefly I talked about it. The derivative allows us, if we're given a function that gives us where an object is at every point in time, the derivative allows us to calculate the velocity of that object at any point in time, at an instantaneous point, because it is the slope of the tangent line. So that is just a consequence. I want everyone just to know that. Let me give you a visual. If this is time, and this is distance, then this function S equals f of t. We're using t instead of x because t stands for time here. So if we're given a position function, let's say for a specific example that distance maybe is measured in miles and maybe time is measured in hours. Then if I go to some point in time, let's call that point A, and I go there and I find the slope of that tangent line, which is really the derivative of that function at A, right? That's the definition now. That's going to be some number, right? Whatever it is. That number is the speed of that object at that point in time. And I think a way you can convince yourself is, remember the derivative is rise over run? Rise over run? Well, when we rise here, that's measured in what? This right here, up and down, is measured in what units? Miles. And then, so the rise is in miles. So on top, whatever this is, it's miles on top, divided by, and then the run is left and right, and that's what? Hours. Miles in the bottom would be hours. So this represents a number that gives you a ratio of miles to hours. Miles per hour, that's your speed, right? That's your velocity. Miles per hour. So that number would be whatever it is. Make sense? All right, we've got 30 minutes. I want to try and see about starting the next section. Do we want another example, or do we want to move on? How do y'all feel? I gave y'all a pretty hard example, so do y'all want something a little nicer, or you want me to move on? Okay, all right, we can do that. Yes?
I was just going to ask if there's going to be problems that are as challenging as that test and probably another example, but if not, then probably move on for now.
The problem I just gave you, I've given that problem on a test, but without the 2 in there. You know how I had 1 over the square root of 2x plus 1? I've done like 1 over the square root of x plus 1. The 2 just throws a layer of complexity into it, but I think that's a fair problem. But it's a more challenging problem. Let's do one more. I'm going to do, let's do an easier one. Yes? Let's do an easier one. This would be like a 1-2, like level 1-2 problem, all right? So if f of x equals x to the 3rd power, find f prime of a. Find the derivative of this function at a, which means find the slope of the tangent line at some arbitrary point a, which means come up with that formula, right? And we get to use either one of the definitions. I'm going to use the second definition again just to have another problem with practice, right? So to find that f prime of a, the formula for this is the limit h goes to 0, f of a plus h minus f of a all over h. That's just my generic formula, right, for the slope of the tangent line, which is the limit h goes to 0. All right, what am I going to do now? What am I doing? What? Huh? What? What am I about to do? Okay, good. Plug in a plus h, right, into that function for x, right? I've given you the function, and now I want you to calculate this. So take a plus h and plug it in here. So I would have a plus h, and then all of that cubed, right? Do y'all agree that's what happens when you plug a plus h into that function for x? I subtract from that f of a, which is what you get when you plug a into this function. What do you get if you plug a in there? A cubed. And then all over h. All right, we got to figure out what that is. Well, what do you think I should do here? Any ideas?
Go ahead and distribute.
Yeah, let's multiply this a plus h out. Let's multiply this out. Right? It's not terrible fun, but we can do it, right? If I do a plus h cubed, that means I have to do a plus h times a plus h times a plus h. I have to do it 3 times, right? That times itself. So when I do this, what I like to do is I like to do these 2 together first. All right? So I go here to here, here to here, here to here, here to here. Everyone knows how to do that little FOIL thing? So I'm going to do a plus h out front. And then when I do that, I'm just going to do it mentally and then collect like terms. You should get a squared plus 2ah plus h squared. Is it all right that I'm not showing that step? I'm just foiling that out and collecting like terms and getting this, right? Now, the next thing I have to do is multiply these 2 together. And this is where students sometimes have problems because they're like, oh, I can do FOIL all day long, but how do you do this, right? All you do here is start with the a, pass the a through, and then after you do the a, you do the h through, and then you're done. There should be 6 multiplications we do. So the first multiplication here, a times a squared is a cubed. Then a times 2ah, I'm multiplying these 2 together. So this gives me 2, I have a squared now h. Then I do a times h squared, so I get plus ah squared. That's passing the a through. So all I'm doing is putting 1 more a in each of these. And then I do plus, and now I'm going to pass an h through to all 3. So I'm just going to add an h to each of those. So a squared h plus 2ah squared, and then plus h cubed. And this is a cubed. All right, do we have any like terms? This right here There's another one of those right here, right? Those are like terms. They both have a squared. They both have h. So I should have how many of those? 3. So 3 of those. And then I also have one of these and 2 of them. So I have 3 of those, right? And then finally I have the h cubed at the end. That's the only reason this problem is a level like 2 problem, is because you have to do this. The rest of this should just be super clean. Limit h goes to 0. All right, all of that cubed became this, a cubed plus 3a squared h plus 3ah squared plus h cubed minus a cubed. Don't forget, you still have to subtract the a cubed, don't you? Like, we figured out what this is, that's this. But we still have minus a cubed, so I put it at the very end. And then all of this over h. Do y'all see what happens here? What happens? A cubes cancel, okay. Does anyone need any clarification on anything? I'm going to keep going, if not. All right. A cubes cancel. Now, let me come up here. What's left now, right? What's left here? Notice that our goal is to get the h to cancel, right? Do you see that everything that's left here has at least one h in it? Right? There's an h here, h squared, h cubed. So watch what I do on the next line. I'm going to put it above this one. In the numerator, because the a cubes are gone, right? Those 2 are gone. I'm going to, out of these 3, I'm going to pull an h out. I'm going to factor like a GCF, right? That's what we call it in college algebra, greatest common factor. I'm going to pull out just one factor of h from each piece. Right? Just one h from each of those. And then I can cancel it, can't I? And all that's left then is limit h goes to 0 of 3a squared plus 3ah plus h squared. Everybody is signed in? Is that yours or? Yes, okay. Yeah. Question? Oh, you need to sign in, okay. Are we all right? We're not done yet, right? One more step. What? Let h be 0, right? Let h go to 0. And it's going to kill off these 2 terms. Those are going to go away now, aren't they? Because h is going to 0, it just kills those. And all that's left is what? 3a squared. And that's your answer. Let's see if you're understanding this. Here's the graph. Here's the graph of that curve, all right? That's x cubed. Can you tell me what the slope of the tangent line is, right, on different places on this curve? What's the slope of the tangent line when I go to the x value of 0? What's the slope of the tangent line there? 0. How are you getting that? It's horizontal. How are you getting that? Are you getting that from the picture, or are you getting that from the formula? Well, both, right? You can see here the slope of the tangent line would be flat, right? Which would be 0. So if you plug 0 in, right there, if you plug 0 into that formula, you get 0. That matches. What would be the slope of the tangent line at 1? So if I go to 1, go up to that point, what's the slope of the tangent line there? We'll plug 1 into this, right? And what do you get? 3. What happens if I go to 2? What's the slope there? I need to bring this out. Let me do it this way. So if I go to 1, the slope was 3, right? If I go to 2, the slope there, it's steeper, right? So it should be 2 into here, 2 squared is 4, 4 times 3 is 12, right? Do you all see that the slope is always positive? No matter what? Because you're squaring, well, it could be 0, but other than that, it's never going to be negative, right? Do you all see it, this graph? No matter where you are on this graph, do you see that the slope of the tangent line is positive? Except here it's 0, but otherwise it's always positive, yes? Okay. Now, for those of you who may know this already, if you've seen calculus, everything we're doing here to get this formula, everything we're doing right now and for the next week or so, is kind of like the torture of Cal 1. You have to do this using the limit. There's 2 definitions. It's a pain in the ass, right? I mean, you can see the algebra can be messy. Where we're going, though, at some point, very soon, 2.3 is where we say, okay, you know what? You've suffered enough. Now we're going to give you formulas to get that 3a squared where you don't have to do the limit anymore. All right? It's like a shortcut. And I can tell you what the shortcut is. On this problem, it's easy to tell you what the shortcut is. All right? See this x cubed? All you do when you have x to a power, and you want to know what that formula is, all you do is you take that power and you drop it out front, and then you just reduce the power by 1. And do you see that that formula looks like that formula? So if I had this, if I had x to the 4th power, and I wanted to know what the magic formula over there was for it, what I would do is I'd bring the 4 out, and then I'd reduce the power by 1. 4x cubed would be the answer there. Understand? So these, we're going to get these later. And then there's other formulas for what if it's not x to a power, what if it's something like sine x, or e to the x, or natural log of x, right? Then what's the formula for that? So we're getting there. All right, we got about 15 minutes. I want 5 more minutes of your time, then I'm happy to talk about the test. We will not start the next section yet. So you know on this problem we had to do this, and the problem we just did, we had to do this a plus h to the 3rd power, right? And we saw how to do that, a plus h. All right, and so we got an answer. What I'd like for us to do is entertain this in a slightly different manner, all right? Instead of doing a plus h, I would like for us to do x plus h, which all I'm doing here is changing the a to an x, all right? I want to ask you something. What is that to the 0 power? So do you all know what anything to the 0 power is? It's not 0, it's 1, right? So anything to the 0 power is 1. So are we all happy with the idea that this is 1? If you're actually going to write this down, you don't have to, but if you are, make sure you give yourself plenty of room for this. All right, y'all agree that that's equal to 1? Okay, what is x plus h to the 1st power? Well, just itself, right? X plus h. So I'm going to center it here. I'm going to write x plus h here. All right, now what's x plus h squared? Well, that one you would have to FOIL, right? You go, you collect like terms. I'm not going to show the work. I'm just going to tell you what it is. I'm sure that all of you could do this, right? And then what if we did x plus h to the 3rd power? Well, we just did that for a plus h, didn't we? And we came up with this formula. So you can look in your notes if you wrote it down. This is what it was. It's here it's x cubed instead of a cubed. 3x squared h plus 3xh squared plus h cubed. That's what we got, but you know, x's instead of a's. Yeah? Okay. What would x plus h to the 4th power be? So there's a pattern here. Do y'all see the pattern? X to the 4th is a good guess for the first piece, right? X to the 4th? That is true, x to the 4th. But then what? Seems like 4 maybe, right? So like look at the second number. This 3, this 2, right? That's 3 was the power here. 2 is the power. Seems like maybe it should be a 4. Yeah? Okay, I'm going to write down what it is. I'm just going to write down what it is, and then you can just trust me. Yes, you're going to trust me? That's what the next line is. If you were to multiply those out, right? 4 of them together, that's what you would get. Collect all your like terms, all right? I'm going to do one more. The next one would be x to the 5th, as you might suspect. And then it's going to be 5x to the 4th h plus, and it's going to be, anyone know? 10 x to the 3rd h squared plus 10 again. Have you seen this before? Okay, you've seen it. All right. And then 5x h to the 4th plus h to the 5th. That's the next one. So obviously I don't, well, not maybe obviously, but I'm not doing this in my head. I'm not doing x plus h, I'm not like multiplying in my head and collecting, that's not what I'm doing, all right? There's a pattern in this, all right? So I want you to just focus all of your attention real quick on let's just look at the x's, okay? Pick any of these rows and just see what happens to the x's. Here, x cubed. In the next one, x squared. In the next one, x, and then gone, right? And that happens in all of these rows. X to the 4th, then x cubed, then x squared, then x, then gone. So you could say that as you move from left to right, the x's start out as whatever power is here, right? That's what they start as. And then they just vanish away, right? Let's look at the h's. What are the h's doing? The what? The opposite, right? So look at this one. Look at this one here. There's no h's, right? There's no h's. Then there's an h. Then there's h squared. Then there's h cubed. And it happens on all these. No h, h squared, h cubed, h to the 4th. So it's doing the opposite of what the x's are doing. Whenever you're on some row here, you're going to have no h, then you're going to have h squared, h cubed, and then you'll stop h to whatever power was out there, right? Y'all following that? So we've covered the variables. So let me do what the next line would be. Let's just talk about the variables. The first thing I should have would be x to the 6th, right? Plus, now I have some number. Let's just not worry about the number right now. What would be the power on x on the next one? X to the 5th. And do I have an h? Yes. Then plus some number. And now the power on x comes down, x to the 4th, and now h power comes up, right? Plus some number, and then I'm going to have x to the 3rd, power on x goes down, power on h comes up, right? Plus some number, power on x goes down, x squared, power on h goes up, h to the 4th. Plus some number, now power on x goes down, power on h goes up. And then one last one. Well, the last one, do y'all notice on the last one it's always just h to that power? So the last one should be h to the 6th. So the only thing left for us to resolve here is what the numbers are. And the numbers come from a different sort of pattern in this thing. So what you're looking at right here is what we call binomial expansions. This is a binomial. And if I ask you to multiply it times itself 4 times, I'm asking you to expand the binomial. These are the binomial expansions. I hope you understand how the powers work, right? On the x and h, the question is the numbers. The numbers come from something the Chinese discovered thousands of years ago, and that is this. I'll do it right here. It's called Pascal's Triangle. Now, Pascal was a mathematician who came much later than the Chinese figured this out. But as many things in history, it's all about who's in power and who's in control at the time. They get to name things, and so Pascal gets the credit for this, but it was discovered way before him. Pascal's triangle goes like this. Notice on all of this thing that you see in front of you, let's look at just the coefficients, just the numbers. I have a 1 here, so I'm going to put a 1. Then on the next row, I have a 1 and a 1. So I'm going to put 1, 1. On the next row, 1, 2, 1. 1, 2, 1. Next row, 1, 3, 3, 1. 1, 3, 3, 1. Okay, let's see if we can see the pattern of this. Do y'all see that there's always 1s on the edges? All right. This next number is a 4, right? That 4 comes from adding those two numbers together. You get 4. And if you take these numbers together, add, you get 6. And those two numbers together, you get 4. And do you see it? 1, 4, 6, 4, 1. The next row would be start with the 1, add those together, you get 5, add those together, you get 10, add those together, you get 10, add those together, you get 5, and then the last number is a 1. And that's this one, right? So what are the coefficients of ours? Start with the 1, now what? These two together, 6. Next one, 15. Next one, 20. Next one, 15. Next one, 6. You're adding them, right? And then 1. And now I could just keep going, right? I can just keep going, going, going. Now I'm going to actually use this in a couple of classes. Can you, well, I want to put it on the board, that way I have it on record. What would x plus h to the nth power be? Ooh, this is tricky. Nth power. See, 6th, 5th, 4th, 3rd. What about n? Well, what would the power on x be? X to the n, right? This would be, the first term would be x to the n, and there would be a 1 in front of it, right? Plus, what would the number be for this one? N. Do you all see that? Do you all notice that 6 was the power here, 5 was the power here, 4 was the power here, 3 was the power here, 2, 1? So the number that comes in front next would be the power we see here, which is n. And now x to what power? Because we had n, we need to make the power go down, right? So subtract 1 from that power, n minus 1. And now an h appears, yes? So we have x to the n, then n times x to the n minus 1 times h, plus, now this next number I'm going to wave my hand at. Okay, let's not worry about the number. What about the power on x? N minus 2. We've taken 2 away from n now. And how about the power on h? H squared. And then this pattern keeps on going until I get to the very end. And can you tell me what the very end is? H to the n. I actually am going to use this in a class or two from now. Well, not next class, that's a test, but I'm going to use that. I'm going to need that. Okay, 5 minutes, sorry, 5 minutes left. Exam, let's talk about it. I sent you a review, right? I said don't just study just the review. I would start with the review, make sure you can do it, and then move on to what? Looking at homework problems, and then go through the class, lectures, right, and take a look at the problems I did in class. If you do that, you feel comfortable with everything, I think, you know, other than little mistakes, you'll at least have some idea of what's coming at you. I'm not going to try and surprise you or shock you with anything that you haven't seen before, but if it's in your homework and you haven't been doing your homework, that's on you, all right? There's nothing more frustrating to me when I give a test and I take problems right out of the homework and students can't do them. Because then that's totally on you, isn't it? All right, so the review. So the first thing I do is I give you, why is it doing that? The first thing I do is I give you some conditions, and then you have to draw the graph. Oh, wait, no. Sorry, I give you the graph, and then ask you to figure out what these limits are. So that was in the very beginning of the class, right? It was about understanding limits visually. So we do that there. The next problem is, I think we did, was this a take-home? Was this I remember I gave you something with this, right? It was in class? Little quiz? I give you conditions and you draw me something, right? You draw me something. So I know we did one of these. So I give you all the conditions, you draw the picture. Everybody's picture is going to look a little different, right? There's a limit. Look at this limit. X goes to 5, you don't get 0 over 0. You just get a number on top of a number, and that's your answer. There's nothing else to do. Don't waste your time. Don't go try and factor difference of squares. You don't need to. You don't get 0 over 0. So this is like an easy problem. The next problem, I believe you do get 0 over 0. So then you have to do some sort of algebra. In this particular case, it's just factoring. And then another limit problem, again, you get 0 over 0, so there's more like factoring, algebra type stuff. Okay, here, conjugate's going to come in because you have a root. Another limit, oh, that was your favorite, right? That was the one where we had to do the sine junk over junk and like peel everything apart and like try and make this one go, like fix this problem, then it creates a new problem. Students hate those. You're going to see something like that on the test, all right? Continuity. I said omit this. We did not cover this in continuity. The thing I could ask you about in this section that would be fair is like a problem I asked you for homework where you had to show that there exists at least one solution to an equation on an interval. Remember I talked to you about that bisection method that computers use to try and find the solution to something, and they're checking for when a function goes from positive to negative? I did it in class. I had you do that for homework. Yes?
Question on those. It was like the last you signed like 43 and 45 or something.
Uh-huh.
It's just kind of like unsure how to do it because they were a little different than your.
Yeah, we'd have to do that outside of, I don't have enough time to do an entire problem right now, but yeah, I mean, you have between now and the test, I have office hours today and then office hours tomorrow. So, and then, oh yeah, Thursday, no office hours, not before the test. Okay, here's a limit where you get a number over 0. And so whenever you get a number over 0, that means it's either going to be infinity, negative infinity, or does not exist. So you draw a number line and you approach and you say, oh, what if I come in from the left and plug a number like 2.99 into this? What happens? Right? We've seen all this, right? We've seen all of it. That's one where x is going to infinity. So you have infinity over infinity. There's a certain technique we use when we see infinity over infinity, right? You look at the highest power in the bottom, you try and make that go away. There's a limit, another infinity over infinity, but you have to be careful because of the square root. Again, I did this in class. There's an infinity minus infinity, and here you factor. You try and factor something out. And now we get to the tangents.